In this tutorial, I'm going to talk about what an equation is. An equation between variables like x and y. There must be x and y, there could be other things, but I have three examples here. So the first one is the equation y equals 2x. So there's two variables here, and all the examples I'm going to talk about will have two variables. So now y equals 2x. Now, one way to graph a relationship is to make a table of values. And we often take x and y values, a few negatives, a few positives. You don't have to take numbers from -2 to +2. You could take other numbers as well, but that's a good place to start. Sometimes you might graph something using a table of values, and it doesn't quite show us enough after you see the graph, so you can make the table a little bigger. Now, what the equation means is it's a relationship between the two variables. So this relationship is that the y values for every ordered pair on this relation are always 2 times the x value. So I can use the equation to find these y values. So if I substitute this -2 in place of x here and multiply, well, this 2 by the x value -2, that gives me -4. So -2, -4 is a point on this relation. Now, if I take my equation and now substitute -1 in place of x, so that's that 2, and this -1 is what's going in place of x here. So 2 times -1 is -2, so that is the y value for an x value of -1. So what we're doing in each case is taking this 2 and multiplying by the x values. 2 times -2 is -4. 2 times -1 is -2. If I substitute 0 in place of x, 2 times 0 is 0. If I substitute 1 here, 2 times 1 would be 2. And if I put this 2 here, 2 times 2 is +4. Now, I'm going to use Desmos to show you the graph of these. So here's the same table of values right here. Okay. Now, notice that they seem to be on a straight line. And what I'm going to graph here now is the equation y equals 2x. And so notice that line goes through all the points. So see every point here, that's the point 2, 4, that's the point, I'm almost on it here, that's the point 1, 2. If I take another point on here, and I'm just going to, a random point, let's say, okay, there's the point 0.51. See, if I take my calculator and go 2 times 0.5, okay, notice I do get 1. So that was the point 0.51. I had about right here, there's 0.51. So with the calculator, see, it's just showing that that was the x value I put in, and that's the y value I put in. I could add that to my table to show you it's another point on the line. So when I said that the equation tells a relationship, the relationship for this particular equation is that the y-coordinate is just 2 times the x-coordinate for every single ordered pair. And you could take some, really random value, like, okay, -2.42, -4.84. So if I go back to my table here, -2.42, -4.84. So that's that point right there. And you see, if I go back to my calculator again and go 2 multiplied by -2.42 and do the multiply, see, it is exactly -4.84. So that point satisfies the relationship because this y value is twice the x value for that point. So let's get rid of this. So let's take a look at another one, a different kind. Okay, so a different kind of equation. So notice this one has a square in it, y equals x squared plus 3. So this means that for every point on this relation, the y-coordinate, the y value, is the x-coordinate squared plus 3. So for example, if I substitute, and I'm going to use -2 to 2 again. Again, I could use different values, but again, often if we have a few negatives and a few positives, 0 is a good one too, we'll get a decent picture of what this relationship looks like. Not always, but often. So I'm going to substitute -2 in here. -2 squared is 4 plus 3, see that's 4, plus 3 will give us 7. So when I substitute this negative 1 in place of x, negative 1 squared is 1, plus 3 will be 4. So that's 4. If I put 0 in place of x, see 0 squared is 0, and then we add 3 to it, will be plus 3. If I put 1 in there, see 1 will actually give us the same value as this one because negative 1 squared was 1. If I put positive 1 instead in there, that's still a positive 1 when you square 1. Plus 3 will give us 4 again. And if I put 2 in place of x here, see negative 2 squared is 4. Remember, when you're multiplying two negatives together, you get a positive. Well, it's the same if I put positive 2 in there. 2 squared is still 4, plus 3 will still give us 7. So those points are on this relationship. So let's take a look at what this looks like. I'm going to bring another Desmos graph over here. And so, see, there's my table of values again. Okay, same numbers are in here. And this is what it looks like. Now, remember the equation was y equals x squared plus 3. So let's put that y equals x squared and then plus 3. Okay. So notice that this curve, we call this a parabola, goes through all of those points. Now, I only used in my table 5 ordered pairs. If we take any other point on this curve, okay, so let's find a kind of arbitrary value here. Okay, so I just clicked anywhere. It doesn't really matter where. So 2.3, 8.29. So let's put that in the table. 2.3 and then 8.29. 8.29. So there's that point right there. And again, if I take my calculator over here again, if I take 2.3 and square it and add 3, see it gives that y value. So that ordered pair, just like the first 5, it's said to satisfy the equation. So the word satisfy is used because it fits the equation. See, if I put any of these x values in place of x here and evaluate it, I get the y value. Okay, so any points, so for example, if I had another point like, let's say I substitute an x value of negative 1.5 in. Okay, if I want to find the y coordinate that goes with that, I can just bring my calculator back again and go negative 1.5 squared plus 3, of course. Okay, gives me 5.25. So if I put 5.25 in here, so there's that ordered pair, negative 1.5, 5.25. So again, that ordered pair satisfies the equation because it makes the equation true. Just to sort of show you a counterexample what I'm saying here. Let's say you thought that if we put, I'll pull my graph down a little bit here more. There we go. So this point right here, for example, see the x coordinate's 3. The y coordinate's 12. So let's say you made so that point right there looks to be, there we go, negative 312. Let's say you make a calculation error, okay, doing your calculator, and you thought that instead of 12 for the y value, let's say you thought it was 13, okay, maybe you made an adding error. So if we go back to the calculator again, okay, so if if I put negative 3 in place of x, and evaluate. So 3 squared is 9, plus 3 is going to give you 12. So see that equation that point doesn't, like the negative 3, 13, doesn't satisfy the equation because the y value should be 12 if we put negative 3 in place of x. Actually, let me move this off. Okay, so here's my equation. Y equals x squared plus 3. Okay, so that point that I said, maybe you made a calculation error and you thought this should be 13. Okay, so if I put negative 3 in place of x here and evaluate, negative 3 squared is negative 3 times 3, so that's 9, and then plus 3. whoops, that should be a 3, which is 12. See, if we thought that this y was supposed to be 13, see, this point doesn't satisfy the equation because the y value on the left doesn't equal what we evaluated on the right. So negative 313 doesn't satisfy the equation, but 12 would. So if I erase this, let's say, you did this correctly. And if we had 12 here, then that point does satisfy the equation because when you substitute negative 3 for x and 12 for y, it has the same value on both sides of the equation. So let's take a look at one more example here. So I've got y equals 3x squared minus 4x plus 2. So if I want to produce a table of values first, so I would take my equation and substitute the x values I chose. Again, I'm using negative 2 to 2, but you could use other values if you want. So I'm going to put negative 2 in place of x here and here. Oh, I meant that to be black. Same as that one. Oh, well, that's okay. So 3 times negative, so that's 4. And 3 times 4 would be 12. And negative 4 times negative 2 is 8. So that adds to 20 plus 2 more would be 22. So that's my y value for an x value of negative 2. So let's put negative 1 in now. So negative 1 here, negative 1 squared is 1 times 3 is 3. So that would be 3. And then negative 4 times negative 1 is 4. Okay, and plus 2. So 3 and 4 is 7, plus 2 more is 9. So that y value would be 9. So if x is negative 1, y works out to be 9. If we put 0 in place of x here and here, now 0 squared is 0. 3 times 0 would be 0, so that's 0. Negative 4 times 0 is 0 as well, so we just get 2. So that y value would be 2. Now when I put positive 1 in place of x, this is pretty similar to the second one. You see, negative 1 squared is 1, just like 1 squared is 1. So that part's going to be the same. What's different is in the middle here. See, negative 4 times negative 1 is positive 4, but this is 4 times positive 1 now. So it's the same calculation as this, except that's going to be a subtract 4. So it'll be 3 minus 4 plus 2. So 3 minus 4 is negative 1, plus 2 is positive 1. And then lastly, the 2. Now again, the 2 is similar to the first one. Again, the difference, the similarity is this. Negative 2 squared was 4, and 4 times 3 is 12. 2 squared is 4 again, times 3 is 12. That's going to be 12 at the beginning. But the difference in the middle here is, see, this was negative 4 times negative 2 give us plus 8. But it's negative 4 times positive 2 for this one. So that's going to be a subtract 8. So 12 minus 8 is 4, plus 2 more would be 6. So there's my ordered pairs, and I'm going to graph those on Desmos. So here's my graph. Okay, so you can see the table is the same as what's here. So there's my 5 points. Now if I graph, so there's the equation. Y equals 3x squared minus 4x plus 2. So notice it goes through all of the points. So all those points satisfy the equation. If we were to take some random point, like for example, looks like my x value is pretty close to 3 there. Going up a little bit. 317. So 317 should be a point on graph. Well, it certainly looks like it. And if I take my calculator and evaluate that, so I'm putting 3 in place of x. So 3 times 3 squared minus 4 times 3, and then plus the 2 in the end. And see, it does work out to exactly 17. So that point satisfies the equation. It makes the left and right sides the same. And we could take some sort of random point in the middle here, like 2.57, 11.535. So 2.57, and the y value is 11.535. Okay, so that certainly looks like that point right there, 11.535. So let's try it in the calculator. And so I punched it in here. So 2.57 is my x value. Now notice the y value doesn't work out to be exactly the same, and I think that's because Desmos is actually just approximating here. It's rounding to 3 decimal places. So the exact value should be 11.5347, but it's just rounding. See, it's rounding to 2 decimal places. But so basically it does satisfy the equation. Desmos is just rounding to 3 decimal places. So what I want you to get out of this tutorial is that any point on any line or curve, as long as you have the equation, those points satisfy this relationship. See, this particular relationship is that all the y values are 3 times the x value squared minus 4 times the x value plus 2. Okay, so that's the relationship for all the points on this parabola, because that's the equation that relates x to y. So that's the idea behind an equation. It tells a relationship between the x and y values for any point on the relation. And that's the end of the tutorial.